Video, I'm going to show you how to do Edexcel A-Level Maths, June 2022, Paper 1, Question 15. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. Please like and subscribe. Question 15 is quite a long question, so what I'm going to do is I'm going to split it over 2 pages. But we'll look at the overall question first of all. So we get this diagram, figure 5. If you look at it, it kind of looks like it's a sector of a circle and then extended downwards to make a sort of wedge shape. So a company makes toys for children. Figure 5 shows the design of a solid toy that looks like a piece of cheese. The toy is modelled so that face ABC, top face is a sector of a circle, radius R, centre A. Angle BAC is, this angle here is 0.8 radians. Faces ABC and DEF, so the bottom and the top are congruent, so they're the same. I guess congruent also could be mirror images, but they're the same, and it wouldn't matter in this case. Edges AD, CF, BE, and are perpendicular to ABC and DEF. So these are vertical lines here, which means that the left and the right, or whatever you call them, are rectangles, and this is a curved side here. And the height of this is h. AD, CF, and BA have a height of length h. Given that the volume of the toy is 240 centimeters cubed, show the surface area of the toy S is given by this equation, 0.8 r squared plus 1680 over r, making your method clear. Well, the first piece of information we've got is the volume. So the volume of the this wedge will be the area of the top times the height. So we can say that the volume here, the area of the top is a half theta r squared and then times the height. So we know theta is 0.4, so half times 0.4, sorry, theta is 0.8, so half times 0.8 is 0.4, so we have 0.4 r squared h, and we know that's equal to 240. And we can see here, when we went S, there's no h's in it, so we're going to need to, our original expression for S, initial expression was going to include h because the height of these rectangles matters. So we're going to have to do a substitution. So by rearranging this, I know that h is, I can express h in terms of r. I can see that h is 240 divided by 0.4 r squared. What about the surface area? Well, the surface area is the area of the top, which is given by a half theta r squared, plus the bottom, which is also a half theta r squared, plus the, I guess the rectangular side, which was ACFD, which is RH, plus the other rectangular side, which would be ABED, which is also RH, plus the curved side. Now the length of this arc is given by theta r, so the curved side is theta RH. That's the curved side. So if we put this all together, this is theta r squared, and we know theta is 0.8. So the first two make 0.8 r squared, and here we've got RH plus another RH plus a 0.8 RH, so we've got 2.8 RH. And now if we substitute for h in that expression here, we know that S is equal to 0.8 r squared plus 2.8 r, and we can substitute for the h, which is 240 over 0.4 r squared, which gives us 0.8 r squared. We've got an r divided by an r squared, so it will be something over r. On the top we've got 2.8 times 240 divided by 0.4, and that gives us 1680, which is the result that we wanted. Okay, so now we've completed part A of the question, and let's now move on to part B. So I'm not showing the diagram here, but we can use this formula that we derived in part A. So using algebraic differentiation, find the value of r for which s has a stationary point. So what we're doing is we're imagining plotting a graph of s against r, and we're looking for a turning point, for perhaps a maximum like that, or perhaps a minimum like that. And at that point, the gradient of ds dr will be equal to 0. So the first thing we need to do is differentiate this. So we know that s is 0.8 r squared plus 1680, and then divided by r is the same as r to the minus 1. So ds dr will be 1.6 r minus 1680 r to the minus 2, which we can also write as 1.6 r minus 1680 over r squared. At the stationary point, be here. At the stationary point, we know that that's ds dr is equal to 0. So this gives us 0 is equal to 1.6 r minus 1680 over r squared. So if we rearrange that, we're going to get 1.6 r cubed is equal to 1680. So r cubed is equal to 1680 over 1.6, and then we can work out the cube root, and r is approximately 10.2, so 3 significant figures. Okay, now the next part, prove by further differentiation that the value of r gives a minimum surface area. So here, remember, we were looking at drawing a graph, and we know that the stationary point is gradient of 0, so it could be a maximum or a minimum. Both of them would have a gradient of 0. Now the way that we can tell is by using the second derivative. So for part C, we're going to differentiate again. So d squared s dr squared is 1.6r differentiated just becomes 1.6. Minus 1680 r to the minus 2 will become times 2 of 1680 is 336. Minus times a minus makes a plus, so it will be 3360 r to the minus 3, which can also be written as 1.6 plus 3360 over r cubed. Now all we need to do is put in this value of r into the expression. So at the stationary point, d squared s dr squared is equal to, and we can put in the 10.2 into this value here. So it will be 1.6 plus 3360 over 10.2 cubed. And if you work that out, it's about, if you do it accurate, it's about 4.8. One significant figure, it's 5. So the most important thing is it's positive. So as the second derivative, d squared s dr squared is positive, the stationary point is a minimum. If it comes out positive, the second derivative, it would be a minimum. If it comes out negative, it becomes a maximum. And that completes question 15.